In this lecture, we're going to learn about recursive functions. And this is a mechanism we have in C++ to get a function to repeatedly call itself and achieve some goal. And a function that has this behavior is called a recursive function. Let's look at a simple example. Here we have a function called sum up to 0. It's going to return an integer, and it is going to basically sum up whatever integer we give it all the way to 0. So for example, if we call this function with an argument of 3, like we are doing down here, the result is going to be 3 plus 2 plus 1 and plus 0. And that's going to be a 6 if you add these guys up. This is what we want to achieve with this function here. But please take a look at the logic we are doing here to achieve our goal. We are saying if the argument we have in the function is different from 0, we are going to return value plus the function. Notice the function we are calling, it is the same function here, but we are saying value minus 1. And let's go through how this function is going to work to really make you understand that this can be really useful. So the first time we call it, it is going to take this value we have in here and say 3 plus sum of 2, or sum up to 2. That's what we should say. Or sum up to 0. And the argument is going to be a 2 because we are passing in value minus 1 and value is 3 the first time we call this function. When this call here is executed, then the evaluation is going to be 3 plus, and we're going to be wanting to do sum up to 0. Now the value is going to be 2 plus sum up to 0, and the argument is going to be a 1 because 2 minus 1 is a 0. Again, here you see we are doing value minus 1. The next time the function is called, because now we're going to be calling it with an argument of 1, we're going to say 3 plus 2 plus 1, because that's going to be the current value. And then we're going to add sum up to 0 and pass in the argument of 0, because the current argument is 1 and 1 minus 1 is 0. The point we hit 0, we're going to see that this guy here is going to fail. And we are not going to execute this body again. What we're going to do is return 0. And we know that if the value is 0, then this guy is going to return 0, because that's what we say here. If the value is not different from 0, we're going to return 0. So here we're going to return a 0, and the result is basically going to be 3 plus 2 plus 1, which is a 6. Hopefully this is clear, but I realize this can be confusing to many people. What I am hoping to achieve here is to make you aware of what recursion is, and that it can be really useful in some applications. But it is notoriously confusing, and many people get this wrong. So if you decide to use recursion in your application, make sure you really spend some time to make sure you understand this. My goal here is to make you aware of what recursion is. Now that we have tried to analyze this simple example, let's head over to Visual Studio Code and see it running. Okay, here we are in our working directory. The current project is Recursive Functions. We're going to grab our template files and put those in place pretty quick. And we're going to open this in Visual Studio Code. The folder is opened here. We're going to close the left pane here, and we're going to clean it up a little bit. And we're going to set up a function which is called sum up to 0. And it's going to take a value. And it's going to take a parameter by value. Let's say value as the name of the parameter. So what we're going to say is if value is not equal to 0, we're going to call the function itself. So we're going to say return value plus sum up to 0, and we're going to say value minus 1. Exactly what we did in the slides. And if this is not the case, if value is actually indeed equal to 0, we're going to return 0. Okay, this is a recursive function. Why? Because it is a function that is calling itself. You see, the name of the function is sum up to 0, but it is going to call itself with some other argument here. And what this is going to do, if we call this function with some number, it is going to be summing up from that number all the way to 0. And it really does this, and this makes sense for positive numbers. So I think we should really change the return value here to unsigned int or size t. So let's do that. And go in the parameter list here, say that we are using size t. This is going to be better and more descriptive of what this function here does. If somebody tries to use it with a negative number, they're going to get a compiler error, and this is going to be a bit safer in my opinion. Now that we have the function here set up, we can try and call it and see what happens. So we're going to say stdc out and say result, why not? And we're going to say sum up to 0, and we're going to give it a 3, the exact same thing we used in our slides. And we're going to see that if we do that, we're going to get a 6. So let's build this with GCC. You're going to see that it is going to work. This is perfectly valid C++ syntax. And we're going to bring up a terminal and clear, as we always do, and run rooster. We're going to get a 6. And if you add up numbers from 3 all the way to 0, you're going to get 6. And if we try to pass in a 10, for example, we're going to get the result. This is going to work, and it is going to recursively call itself to give us the result that we want. So we're going to call rooster, and this is going to be 55. And I am sure if you add up numbers from 10 all the way to 0, you're going to get a 55. Let's actually bring up a calculator and prove that. So we're going to run this, and we're going to say 10, we're going to say 9, we're going to say 8, we're going to say 7, we're going to say 6, we're going to say 5, we're going to say 4, we're going to say 3, we have 2, we're going to say 1, we're going to add 0. If we say equals, we get a 55, and this is exactly what we have here. So the function is doing what we want. Please, again, know that recursive functions can be very confusing to many people. So make sure to spend some time and really make sure your logic is working according to your specifications if you decide to use recursion. One big benefit of recursive functions is that they are really short. If you look at this function, it is just 3 lines in the body, but it is doing something fairly complex. If you try to use some other logic to do this, I am sure you're going to have more than 3 lines to achieve this. So the functions that use recursions are mostly shorter, but they are confusing because looking at this function, you can't really know what it is doing until you spend some time and try to really decrypt what the function is doing. I personally try to avoid recursions in my programs because I value readability more than doing something a little bit clever. But that's going to be your decision. My job here is to make you aware of the facilities that the C++ programming language provides. And in this case, we are exploring recursive functions. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.